Good day everyone, you are welcome back to class. Now today we are going to be looking at trigonometrical ratios of special angles, and the angles we are going to be considering is 30 degrees, 45 degrees and 60 degrees. Now, given this triangle you are seeing on the screen, this is a right angled triangle. So let's label this triangle. We have A, we have B and we have C. Okay, if line AB is 1 and line BC is 1, so this is the right angle, 90 degrees. Alright, so it means this angle A will be 45 degrees and this angle C is also 45 degrees since it's a right angle triangle. Understood? So we want to use this angle to find angle 45, we want to use it to find sine 45 degrees, cos 45 degrees and tan 45 degrees. Okay, so let's begin. I'm going to apply Pythagoras theorem to find the value of line AC. AC here is the hypotenuse. And you know Pythagoras theorem says that the hypotenuse square is equal to the square of the other two sides of a right angled triangle. So I'm going to have AC squared is equal to 1 squared plus 1 squared. Okay, so AC squared will be equal to 1 squared is 1 plus another 1 squared is 1. So AC squared is equal to 1 plus 1 is 2. So when you take the square root of both sides, you have your AC to be equal to root 2. Understood? So this side AC now is root 2. So now that we know the three sides of this right angle triangle, we can go ahead and find the value of this special angle, angle 45. Okay, the sine 45, cos 45 and tan 45. Now let's begin with sine 45 degree. So you remember the SOH CAH TOA I told you about? That's what we are going to be making use of. Sine 45 is the SOH of the SOH CAH. Let me keep it here so that you will be looking at it. SOH CAH TOA. Okay, so sine 45 is opposite over hypotenuse. So and what is opposite here? Our opposite here is 1 if you are considering this angle 45. Okay, well, if you still consider this second 45, you still get the same thing. Understood? So our opposite is 1, then divided by hypotenuse is root 2. Okay, so sine 45 is 1 over root 2. Then what about cos 45 degree? So cos 45 is the formula is adjacent divided by the hypotenuse. So our adjacent is 1 over the hypotenuse is root 2. Okay, so 1 over root 2, that's cos 45. You can see that sine 45 and cos 45 are equal. So you can even confirm that with your calculator. Press sine 45 and cos 45. It will give you the same answer. Then we have tan 45 degrees. So tan 45 is opposite over adjacent. Alright, our opposite here is 1 and the adjacent is 1. 1 divided by 1 is 1. So tan 45 is given to be 1. So if you press your calculator now and you press tan 45, the answer you are going to get is 1. Understood? So these are the values of sine 45, cos 45 and tan 45. Now let's go ahead and find for the other two angles, which is 30 degrees and 60 degrees. Now we are going to be using this figure you are seeing on the screen to find the other special angles. So this is an equilateral triangle. Let's label it. Let's call this part A. Okay, B and C. So the sides of this equilateral triangle, since it's an equilateral triangle, all the three sides are equal and the three angles are also equal. Okay, so the angles of equilateral triangle are 60 degrees each. 60 degrees. Then this one also is 60 degrees. Then this angle is also 60 degree. But because we have divided it into two equal parts, so we will now be having 30 degrees, 30 degrees, because 30 plus 30 is 60 degrees. So all the three sides, like I said, are equal. So this side AB will be 2, this side AC is also 2, and we have divided it into two equal parts, like I've said. So let's call this point B, so that line BD will be 1 and line DC will be 1. Is that understood? Okay, so for us to find our sine 30, cos 30 and tan 30, let's just bring out one out of these two triangles that you are seeing on the screen. Okay, so let's bring this out. Okay, so we now have A, B and D. So this side is 2, this side is 1, and here we are having 60 degrees and here we are having 30 degrees. So before we continue, let's try and know this third side of the triangle, that is this line AD. We have to know that first before we can continue to find cos 30, sin 30 and tan 30, and even for the 60 degrees. Understood? So let's apply Pythagoras theorem on this triangle. So we know that the hypotenuse squared is equal to adjacent squared plus the opposite squared. All right, so we have AB squared, all right, will be equal to AD squared plus BD squared. So that's what Pythagoras theorem says. Then what is our AB? AB is 2 squared, then equal to AD, that's what we want to find, AD squared, then plus BD squared is just 1 squared. Okay, if you collect the like terms, okay, before that, 2 squared is 4, then equal to AD squared plus 1 squared is 1. So if you collect the like term, we have 4 minus 1 equal to AD squared. So we now have 3 equal to AD squared. Alright, so finally you can just conclude and say AD all squared is equal to 3. If you take the square root of both sides, you now get your line AD to be equal to root 3. Is that understood? So this side AD is giving us root 3. Alright. So now if this line that divided this triangle into two equal parts is root 3, we can now go ahead and find the cos theta, which is cos 30, cos 60, sin 30, sin 60, tan 30 and tan 60. Alright, so let's quickly do that. Now considering this triangle that we have here now, alright, so that's what we are going to be using to find the other special angle. So let's find first of all sin 30. Sin 30 degrees will be equal to, so we are consider this angle here, this 30 degree. So you know where this angle is facing is side BD, so that will be opposite. Okay, and our hypotenuse is the longest side, as you know before. So sin 30 is opposite over hypotenuse. The opposite is 1, then the hypotenuse is 2. Alright, now let's find cos 30 degrees. So cos is adjacent over hypotenuse. So our adjacent is root 3 divided by the hypotenuse is 2. Alright, so that is the value of cos 30. And then tan 30 degrees is opposite over adjacent. The opposite is 1 and the adjacent is root 3. Okay, so that is tan 30. But if you rationalize this 1 over root 3, you are going to get root 3 over 2. Is that okay? So both answer are equal. If you press 1 over root 3 in your calculator and you also press root 3 over 2, you are going to get the same answer actually. So let's continue. So those are the sine 30, cos 30 and tan 30. Now let's go ahead and find sine 60 degree. So what will be sine 60 degree? Now we want to consider this angle now 60 degree. Where this angle is facing will be our opposite. So our opposite now will be root 3. The adjacent is BD, which is 1, and the hypotenuse remains AB, and which is 2. Is that okay? So now what will sine 60 be? Sine 60 is opposite, which is root 3 divided by the hypotenuse, which is 2. Then cos 60 degree, that will be adjacent, which is 1 over hypotenuse, and that is 2. And then tan 60 degree is equal to the opposite. Tan 60 is opposite, which is root 3 divided by the adjacent, and the adjacent is 1. So meaning that tan 60 is equal to root 3. Understood? So those are the values of the special angles that we have. Now let's take a look at some examples. The question says find x and y in the angles below. So we have quite numbers of some angles here that we want to find x and y. Alright, so the first angle here is what you are seeing on the screen. So let me quickly label it. This side is y, this side is x, this is 3, this side is 3, and the angle here is 45 degrees. So we want to find the value of x and then the value of y. Alright, so we will apply the special angles that we got now to these questions. Alright, so if you apply tan 45 to this triangle, okay, so tan 45 is opposite over adjacent. So the opposite is x and then the adjacent is 3. Okay, now if you cross multiply, you get your x to be equal to 3 tan 45 degrees. Then your x will be equal to 3 times, what is tan 45 degree? The special angles that we just finished finding, tan 45 is given as 1. Okay, so x is equal to 3 times 1 will give us 3. So that is the value of x. Alright, so now let's find y. Now that we know two sides of this triangle, we know side 3 and then x now is also 3. We can go ahead and find the side y using Pythagoras theorem. And if you don't want to use Pythagoras theorem, you can still follow through the first method that we follow to find the value of x. But I'm going to use Pythagoras theorem now. The hypotenuse squared, which is y squared, is equal to x squared then plus 3 squared. So our y squared will be equal to, x is calculated to be 3, so 3 squared plus 3 squared. So y squared is equal to 3 squared is 9 plus 9. Then y squared is giving us 18. So when you find the square root of both sides, our y will be equal to root 18. Okay, and root 18 can further be simplified as root 9 times 2, because 9 times 2 will give us 18. Alright, so y is equal to, split it, root 9 times root 2, and y is equal to root 9 is 3 times root 2, and finally y is equal to 3 root 2. Understood? So this is the solution to this question. So let's move on to another question. Okay, so we are given this triangle and it's labeled as 5x and then y. So this angle is given to be 30 degrees and this side is 90 degrees. We want to find the value of x and y as well. Solution. Okay, so I'm going to use any of the identity that will capture x and 5. Okay, and what I can use that will capture x and 5 is sine 30. Sine 30 degree, because sine 30 is opposite over hypotenuse. And what is my opposite here? My opposite is x divided by the hypotenuse, and the hypotenuse is 5. Okay, so cross multiply, you have x, just put like over 1 here. Understood? So x times 1 will give you x equal to 5 times sine 30 degrees. So x is equal to 5 times sine 30 from the special angles that we found is 1 over 2 half. Okay, sine 30 is 1 over 2 or 0.5. So x is equal to 5 times 1 over 2 will give us 5 over 2, or you can write it in mixed number, which is 2 whole number 1 over 2. Now let's find the y. So I'm going to look for one of the trigger identity that will capture y and the hypotenuse, which is 5. Okay, and that identity is cos 30 degrees. So cos is adjacent over hypotenuse. Adjacent is y, hypotenuse is 5. Okay, so if you put like over 1 here and you cross multiply, you have y equal to 5 cos 30 degrees. So y is equal to 5 times cos 30 from the special angles that we found is root 3 over 2. Okay, so y is equal to 5 times root 3 is 5 root 3 divided by 2, or if you change 5 over 2 to mixed number, you have 2 number 1 over 2 root 3. So that is the value of y. Understood? Okay, so let's take a look at another question so that we understand this thing properly. So you see this shape given to us. Here we have 10, here we have y, and here we have x, and this is 60 degrees. Okay, and this is 90 degrees. We want to find x and y. So the trig identity that will capture first of all y and 10, okay, that is the opposite and the hypotenuse, is what? Is sine. Sine 60, sine is opposite over hypotenuse. So opposite is y over hypotenuse, which is 10. So if you cross multiply, you have y is equal to 10 times sine 60 degrees. So y is equal to 10 times sine 60 from the special angles is root 3 divided by 2. Okay, so y is equal to 2 here is 1 and 2 in 10 is 5. So we have 5 times root 3. So which is equal to 5 root 3. Then to find x, you can use Pythagoras theorem if you wish, but let's use trig identity. So I'm going to look for a trig identity that will capture this x and then the hypotenuse, and cos 60. Cos will do that for us because cos is adjacent over hypotenuse. So our adjacent here is x divided by hypotenuse, which is 10. So if you put over 1 here and you cross multiply, you have your x to be equal to 10 multiplied by cos 60 degrees. Okay, so x is equal to 10 times cos 60 degrees from the special angles is 1 over 2. Okay, so we now have x is equal to 10 over 2, and then 10 divided by 2 will give us 5. All right, let's take a look at another question. So this diagram you are seeing on the screen is labeled as, this side is y, we have 2 here, and this angle is 60 degrees. This line here is x, and we have 45 degrees here. So, and this is a 90-degree right angle triangle. So understood. So this place also is a right angle, okay, 90 degrees. So we want to find x and y, and this is where x is. Okay, you can see our x here. So we want to find that x. So let's find x first. For me to find x, I want to let me bring out the triangle I want to use. So I want to use this second triangle which you are seeing on the screen now. So here is 60 degrees, this place is 2, and this place is x. All right, so the trig identity that will capture x and 2 is a tan 60 degrees. So tan is opposite over adjacent. The opposite here is x, and the adjacent here is 2. Now when you cross multiply, you have x to be equal to 2 times tan 60 degrees. Okay, so x will be equal to 2 times tan 60 from the special angles is root 3, and when you multiply together you get 2 root 3. So that is the value of x. Now let's find the value of y. So I'm going to do that with this second triangle here. Let me draw it also. Okay, so this second triangle. So here is x, and the angle here is 45 degrees. Here is our y, and this is 90 degree. So which of the trig identity we captured my y, the unknown side, and this x? Okay, using this angle 45. So when we use sine 45 degree will be equal to, sine is opposite over hypotenuse. My opposite is x, hypotenuse is y. Okay, so put over 1 here, and when you cross multiply you have your x to be equal to y times sine 45 degrees. The value of x has been calculated to be 2 root 3, then equal to y times sine 45 degrees. Okay, so dividing both sides by sine 45 will give us y to be equal to 2 root 3 divided by sine 45 degrees. Okay, so y now will be equal to 2 root 3 divided by sine 45 is given as 1 over root 2. 1 over root 2 from the special angles. Well, you can write this as y is equal to 2 root 3 then divided by 1 over root 2. Okay, so let's change this division to multiplication, and then when we change it to multiplication, this 1 over 2 becomes root 2 over 1. Okay, so now multiplying this together, we have 2 times root 3 times root 2, everything over 1. Okay, so 2 times root 3 times root 2 will give us 2 root 2 times 3 is 6. So that is the value of y. Thank you for watching. Bye.